Welcome back to AIM Chemistry, Learn Chemistry with Dr. Poonam. Today's lesson is about pH and how it is related to H plus and how we can calculate it for mainly strong acids, strong alkalis and weak acids. So students, here we need to use for strong acids and strong alkalis we need to use a very simple formula. It is a very easy to calculate pH for strong acids and strong alkalis, and for weak acid we need to use another formula which is based on dissociation constant. So step by step we will learn how to calculate pH. First we will calculate pH for strong acid, strong alkalis, weak acid. In addition to it, we need to calculate hydrogen ion concentration for strong acids, strong alkalis and weak acids. So let's begin, students. So the first question is, what is pH? So we should know that what is meant by pH. So pH is a scale, as we know that because every time we are studying this pH scale. It is a scale, pH is a scale that measures how solution acidic or basic. It gives you identity about its acidity and alkalinity. What does mean by pH? pH is a simple scale that measures how solution is acidic or basic. And now student, we need to calculate pH. So pH is calculated by simple formula. This formula is pH is equal to negative logarithm to the base 10 hydrogen ion concentration. If it is base 10 is not given, no problem, it is assumed that. By using this formula we can calculate pH of any solution. And at the same time, when we need to calculate hydrogen ion concentration and when pH is given, just by doing simple rearrangements, hydrogen ion concentration is equal to 10 raised to the power negative pH. By doing this rearrangement, student, you can calculate H plus also. If pH is given, you need to use this formula. If pH, you have to calculate pH, you need to use this formula. And if hydrogen ion concentration, you need to rearrange this formula. One important thing that maybe you know this, when this is a pH range, when pH is in between 0 to 6, we call it acidic condition. When pH is 7, it is neutral condition. High pH from 8 to 14, condition is basic. It means solution is basic in nature. And one more important thing. So when you are relating this pH to hydrogen ion concentration, it is a log 10 H plus ion concentration. So student, concentration of H plus increases but the value of pH always decreases. Or in an opposite way also we can say like that, when concentration of H plus decreases, pH is increasing. So when if you can see that when the concentration, here we can take it like that, 10 to the power minus 1, that is a 0.1. Concentration of hydrogen ion is 0.1. So as comparing this 1 and 14, pH is 1 but hydrogen ion concentration is highest here. So in this case, student, they are related. So when you see more hydrogen concentration, that time your pH should be less, and if your pH is more, that time your hydrogen concentration should be low. So without wasting time, student, we will come to direct calculations. So you can note down this formula, or here also maybe you noted down definition of pH. You just pause video and you note down definition of pH. Then concentration of H plus increases, pH decreases. Later on, we will calculate the pH of 0.0 mole per dm cube HCl solution. Student, to calculate this pH, again we have to use this formula. pH is equal to negative log 10 to the base 10. If you will not write it base 10, it is okay. Now, but when you have to calculate, we know that we need H plus ion concentration. As student, we are calculating pH for strong acids. We are calculating pH for strong acid. So when we calculate pH for strong acids, that time the concentration given for acid, mole per dm cube, this is the concentration of acid. So whatever concentration given for acid is equal to concentration of H plus, because HCl is monoprotoic acid and it is strong acid which completely dissociate into hydrogen ion. And this is the reason when whatever concentration of HCl is given, this concentration is equal to H plus. So concentration of HCl is equal to 0.005. That means it means that the concentration of HCl is 0.005. That it means that the concentration of H plus is also 0.005. Just put this value in this formula. pH is equal to, keep your calculators also ready, students, 10 0.005. Just calculate and you can comment now. So answer is, students, I calculated 2.30. You can recheck this answer. So in this way we have to calculate pH of strong acids. First, note down formula. Then second, find out concentration of H plus, where concentration of HCl is equal to concentration of H plus because it's a strong acid. So put this value in formula and directly by putting in calculator you will get answer. Let us take one practice problem. So same, the number one step is put formula pH is equal to negative log with the base 10 H plus. So here it is nitric acid. Nitric acid means HNO3. Again nitric acid is strong acid. So when we are writing strong acid, and here in this problem, student, directly H plus concentration is given. So there is no confusion. So negative put directly in calculator. 2 into 10 to the power minus 2 mole per cubic decimeter is the concentration of H plus. So you will get answer. Approximately we get answer of 1.7. So students, you can see that when concentration of hydrogen ion is increasing, your pH is decreasing. Now this is some practice problems, students, so we are not going to focus on many problems. So just then after we will calculate hydrogen ion concentration, hydrogen pH, hydrogen ion concentration, the concentration is shown by square bracket, okay, from given pH. So this is again very easy, as we know this formula, we need to just rearrange. pH is equal to negative log 10 H plus, and just rearrange this formula. H plus is equal to 10 to the power negative pH. So put whatever value you have, students. So it's a 10 to the power, the pH is given 1.6. just put it into calculator and you will get answer. You can pause video and you can calculate. So it is equal to 2.51 into 10 to the power minus 2. When you are writing concentration, when you are calculating concentration, here you should mention unit. The unit of concentration is mole per cubic decimeter, or you can write it like this also, mole dot dm cube inverse. So in this way, students, we studied how to calculate pH from hydrogen ion concentration and how to calculate hydrogen ion concentration from given pH. There are many problems. If you need notes, just write your comments. I will provide you all required notes for grade 12 bilingual. So now students, you can take screenshot and you can try this problem. So in this way students, we have finished how to calculate pH for strong acids.